Welcome back to my online video tutorial series. For this video, I will be focusing on skew lines. For this example, my objective is to find the shortest horizontal distance on the front and the plan. So we want to find the shortest horizontal distance between both lines on both the front elevation and also on the plan. The technique here is basically the same for finding the shortest horizontal distance, but the difference here is for horizontal. With horizontal, some techniques are somewhat different. I went ahead and I started drawing up my parallel line. So I copy line CD to B to get this line. So the first step is to ensure that CD is parallel. Draw a line parallel to CD at the end of B. And whatever you do on the front must be done on the plan as well. So here I copied line C1, C prime, D prime to the end of line B to get this. I then draw a horizontal line from point A. At the point where that meets, I then draw a vertical line downward to cut this parallel line. At the point where it cuts the line, label that point O prime. Now, my next step is to find the true length of A prime, O prime. So I draw a line from A prime through this, extend it outward. The next step is to draw lines parallel to A prime, O prime to pass through all the other 3 points. So my first step is to align my set square with this line. I then draw a line here. If you're using AutoCAD, you would basically select copy, specify the base point. If you were to use AutoCAD, you would select copy. You select A prime, O prime. Then you select here as the base point, then you touch the end of the other 3 lines to get these lines perpendicular. These videos assume that you know how to use AutoCAD to do this, because at A advanced level / CAPE, you're expected to do this in AutoCAD, but AutoCAD takes a lot more time. The purpose of these videos basically is to help you to understand the concept and the principle under which these questions are to be done. You're expected to apply AutoCAD to do these. So my next step is to draw a perpendicular line at a suitable distance here. So I choose to draw my perpendicular line here. So this line should be perpendicular to the parallel lines that we just draw. Let's label this X1, X1, Y1. Our next step is to transfer the distance. Transfer is a step back 2 plane. So this is our auxiliary inclined plane. So we're gonna set back 1 view, working here, 2 views, and transfer these distance onto our elevation right here. So for that, I'm gonna use a piece of paper, and you could use a compass if you want. So for here, this is A. So I look for A line, I then trace this back to A line. A is here. I then transfer that distance here. This is A. This is A prime. I then go across to B, go across to point B, and I transfer B distance. I locate B line, so B is here, and B comes across here. So this is B. then transfer B distance onto that line. B. I then go across to C, and I then transfer the distance of C. This is C. I track C here. C comes across here, and I transfer the distance of C onto this line. C. I then go across to D, and I track D all the way across to here, and then transfer D onto this. I then join A to B, then join A to, oh, so this is D, this is D2, this is D2, C2, C, this is B2, C2. It is very, very important that you label these points as you go. So A to B, which should be like here. So these are very, very close, very, very close. A to B is like here. C to D is here. Oh. So these points are supposed to be parallel. If these lines are not parallel, it means that something is off. All right. However, I will continue. But once you transfer these measurements correctly, you should get two parallel lines. All right. So my next step now, if you're trying to find the shortest, the closest or shortest possible distance, you would draw a perpendicular line to these parallel lines. But because we want the shortest horizontal distance, once it is horizontal distance, we must produce these points parallel to the auxiliary inclined plane, to this plane. So the technique here is different. For shortest horizontal distance, we must draw those points parallel to x1, y1. So I align here. We draw parallel lines through these points. Our next step is to establish a horizontal line here, or our auxiliary plane. So we draw a line perpendicular to those lines. We label this one x2, x2, y2, x2, y2, yes. Then we follow the same procedure wherein we transfer measurements 2 views back. So we are working in this view. We have one view here, next view here. So we're gonna transfer these measurements from this plane onto this plane right here. All right. You'll realize that this is some distance away. So I could bring this line, this plane up a little bit and transfer the measurement, or I could use those very same measurements. So our next step here is to transfer the distance from x1, y1 to each of these points on the corresponding value here. So what I did here, you'll notice that the distance here is a little long, so I draw a parallel line here. I bring this line up a little bit and then measure from here to that point. Yeah, so I actually bring this line up a little bit, then measure from here to there. That doesn't affect anything, all right? So that's basically what I did. I transfer all the measurement from here onto this. I know I'm going to plot these points. So A2 to B2. And C2 to D2. And at the point where both lines cross, we're going to draw that line parallel to this line right here. Then we're going to bring them across. So let me do that quickly. So I draw a parallel line here. Parallel line across to this. Yeah. And I'll then bring that down to this point right here. And now from here to here, here is the shortest possible distance, shortest possible horizontal distance. This is the space right here. I then bring those across, bring those 2 points across. This is very tiny, by the way, very, very tiny. Shortest horizontal distance on the elevation. Now to find the shortest horizontal distance on the plan, I bring those 2 points across. So I align this up like here. And I bring this across like here. Yeah. And here is the shortest horizontal distance. Right here. Shortest horizontal distance. I then bring these 2 points up to the front elevation by, of course, using parallel lines again. And from here to here is the shortest horizontal distance. By the way, this seems to be a vertical line. Yeah, it seems to be a vertical line. So I just bring those 2 points up. So this is the shortest horizontal distance on the plan. So you'd measure from here to here, measure from here to there. That works out to be 9. Shortest distance here, this works out to be 4. And shortest horizontal distance here is this tiny distance here. This seems to be about 3 millimeters. This is not very visible. So that is it. So let me just repeat a little bit. To find the shortest horizontal distance, once we get the parallel lines, we bring those points parallel. We draw them parallel to the auxiliary inclined plane. We then step back 1, 2 views and then transfer the distance here onto this. It should create a X. At the point where both lines cross, we produce that line down to the auxiliary, to the parallel lines. And that distance is our shortest horizontal distance on that view. We then produce those lines across to the plan, and that distance now is the shortest horizontal distance on the plan. We then bring those points up to the front elevation and then highlight this distance. This now is the shortest horizontal distance on the front. So that's basically how this is done. I hope this video